Hi there, Dr. Trottier.
Alice, call me Howard, and welcome to the Trottier Observatory at Simon Fraser University. You've arrived just in the nick of time. I finished setting up this telescope to look at the sun.
But Howard, isn't it dangerous to look directly at the sun?
Excellent question, Alice. One should never look at the sun, even by eye, without proper equipment. This telescope is made to look at the sun. It has a special filter that cuts out almost all of the sun's light, so it's safe to see. Did you want to have a close-up look at the sun yourself?
Wow, there really is a lot going on.
Well, the sun is a giant ball of hot gas, Alice, and it has protons, electrons, and other particles that are flying around and colliding with each other all the time. You see those eruptions near the edge of the sun's disk? Those are called the solar prominences, giant streams of gas being blasted out into space. And there's also those dark spots. Those are sunspots.
But Howard, I thought the sun was just plain yellow.
Well, Alice, the sun emits an enormous amount of energy, and a lot of it is in the form of light that we can see with our eyes, but much of it is in the form of colors that we don't see at all. So if you come on inside the observatory, I'll show you more about what we're talking about. So, Alice, this telescope can show us the individual colors of light that the sun produces. We actually can't point it directly at the sun. Instead, we use scattered sunlight from a safe part of the sky. And so, the sun, as you probably know, is the closest star to us, so we study it an awful lot. And we can learn a great deal about the stars by studying their colors really precisely.
How does it show us individual colors?
Well, it spreads the light apart into its colors in a pattern we call a spectrum, kind of like a rainbow. It uses a device called a spectrograph to do that. And if you've ever seen light reflected from a DVD into its different colors, it works in very much the same way. And by studying different colors and different wavelengths of light, we understand a lot about the stars. And so let's look at the spectrum of the sun as an example.
Wow, cool. Can you use a spectrograph to look at other light sources? And would their wavelengths be different from those of the sun?
Well, those are great questions, Alice. You're going to have to visit Sarah in the classroom to find out.
Hi, Sarah. I have some questions about light and spectrographs.
I teach physics here at SFU. I could show you this simple spectroscope we have here. It works very similarly to the spectrograph that you saw in the observatory. We could try looking at some different types of light bulbs with it. Let's start with the incandescent light bulb. So, what do you see? How does the spectrum of the incandescent bulb compare to the solar spectrum?
It looks a lot like the spectrum of the sun. It's also a rainbow. I can see the same colors in the same order.
So why do you think that is? Like, what's the same between a filament in an incandescent light bulb and the sun?
They're both glowing?
Right, and why do they both glow?
I'm not sure.
Well, think about what they both emit.
Heat?
Exactly, they both emit heat, they're both hot. And when something is hot, it emits what's called a continuous spectrum, which contains all of the different wavelengths of visible light. So now what we're going to do is try and look at a different type of light bulb, what's called a compact fluorescent light bulb. How is this light bulb different than an incandescent light bulb?
This one doesn't get as hot.
That's right, it also uses less electricity. Let's try looking at it with the spectroscopes. So what kind of light spectrum do you see from the compact fluorescent bulb?
I see almost all the colors of the rainbow, but this time they look different. The colors are in separate stripes and they're not a smooth rainbow. Is this because a compact fluorescent bulb makes light in a different way?
Yes, that's exactly it. In a compact fluorescent bulb, there's a gas that gets excited by electricity. That causes the electrons in the atoms to jump up to higher levels, and when they come back down, they emit light in the form of particles we call photons. It's actually the same reason why you see dark stripes in the solar spectrum.
Hey Alice, so did you find the answers to your questions?
I sure did. I can see how this helps astronomers learn about what stars are made of. What else do astronomers use spectroscopy for?
Well, we've used our equipment to see what stars are made of. We've measured how hot stars are and how fast they spin. We've measured how fast stars and whole galaxies of stars move through space. And we've even detected a planet around another star. So astronomers use spectrographs to study these and many other cool things about the universe.